this is Soundarya. Welcome to Study Zone. So in this Study Zone, the first playlist is Discrete Mathematics and Optimization. So under Discrete Mathematics and Optimization, I am going to explain about propositional logic. So the topics I am going to cover is example of propositional logic, logical connectives, truth tables, tautology, contradiction and contingency, predicate logic, logical equivalence, rules of inference and proof techniques. So under proof techniques there are several methods. They are direct method, indirect method and proof by contradiction. So here the basic thing is you have to get to know about the propositional logic, because the base should be proper to get to know about all these things. And truth tables, this also plays a very important role in propositional logic. And then predicate logic is also very important, and these proof techniques are also important. So those who want to attain seats in NET exam and GATE, and those who are UG students, PG students and BE students can take the help of this project to get to know about these topics thoroughly. So I am creating the playlist for this topic. So if you go through this playlist very clearly and if you maintain consistency, I am assuring you that propositional logic will become a very easy topic for you. So at first video of our playlist, let us go through example of propositional logic and let us define what is propositional logic and all. Okay. So sometimes we all think, right, how computer take decisions or how human beings interpret two statements. Example, so it is raining, that's why I will take an umbrella. So we have to connect to two sentences, right? So these are get to know about with so these can be done with the help of propositional logic. So as the name suggests, propositional logic is composed of two words. One is proposition, another one is logics. So propositions are the statements which are either true or false. So these proposition statements have always an truth value, which would be either true or false. The statements which is either true or false the statements which are either true or false should only come under the propositions. So this is about proposition. So let us take some examples so that you can understand what is proposition. So example for propositions are 5 greater than 3. It is true, right? So this is proposition. And then it is rhyming. So now in my place it's not rhyming. So what will happen? It is false. So here two statements have either true or false value. So this comes under proposition. So next, non-examples, which means the statements which do not come under propositions are what time it is. I can say 6 p.m. or 7 p.m. anything like that. Here you can't say what time it is. So if someone asks what time it is, you can't say yes or no for this statement, right? So it doesn't come under proposition. And then another example is close the door. Here also you have to do action, right? You have to close the door or else you shouldn't close the door. You can't say yes or no for this, because here there should be action performed. So these will not come under proposition. So here we have seen some of the statements, right? 5 greater than 3. It is rhyming. These are proposition. Drawing conclusion from these, which means 5 greater than 3. So here what we are doing, we are deriving a conclusion for this statement, right? So to derive a conclusion for this statement, we need logics. Logics, we all know about logic, right? Logic means we are getting some conclusion for the statement. So logic helps to attain conclusion. Mainly what we are doing is we are attaining conclusion for the statement. So with the help of proposition, so propositions are the statements which can either be true or false. So some of the example we have seen about proposition. So simply taking, if so let us take one example, that is 3 plus 2 is equal to 5. What is the answer for this? We all know it, right? It is true. So this is proposition and this is the logic behind the proposition. So combination of this will helps to take the final decision. So we came to know that with the help of propositional logic, computers take the decision. So propositional logic plays a very important role in computer science to take decision. So this is about propositional logic. So let us go through some of the examples to clearly understand what is propositional logic and examples of propositional logic. So now coming to the examples of propositional logic. So 3 plus 2 equal to 5. So what will be the answer? 3 plus 2 equal to 5. It is true, right? So we come to the conclusion that this is a true statement. And then I am studying. Now you are all watching my video, which means you are gaining some knowledge, or which means you are studying, right? So this is a true statement. And Arjun is intelligent. So I have a friend named Arjun. He is intelligent. That's why I am writing true. If you have any friend Arjun who is not intelligent, you can write it as false. So weather is too good. Now here weather is not too good because it is very sunny. So I will write it as false. Next, Seema, are you crying? So here what will you write? You will write it is a proposition. But here when there is a question mark in a statement, it doesn't come under proposition. So this statement we can't take it as proposition. So these are all the statement we can take it as proposition, and here this one we can't take it as proposition. Okay, so these are some of the examples about propositional logic. So now I will give you some homework about the examples of propositional logic. So if you understand the topic, you can easily clear the examples, right? So answer this example, and in the comment section please comment what are all the answers. Okay, so the questions are, so I have given you some of the questions, and the questions are: Paris is the capital of France. What time is it? 2 plus 2 equal to 4. Open the door. The moon is made of cheese. It is raining. Are you dancing? I am dancing. So some of the questions I have solved in the classes. So please don't rewind the playlist and check the answer. Do it for yourself and answer this in comment section. If everyone answer it rightly, I will for sure give you the notes of mine. So the main thing for propositional logic is notes. So I will obviously give the handwritten notes of mine to you all. So answer it properly and please listen to the class carefully. So the next topic is complex propositions. So in the complex proposition, what we are doing is we are combining two propositions or modify the proposition. So the main thing you should remember is that we are going to combine the propositions or modify the proposition. So to combine the proposition or modify the proposition, the main thing we need is connectives. They are, do you understand? The main thing we need is connectives. They are also called as logical connectives. So, with the help of logical connectives, we are going to combine or modify the proposition. So, with the help of logical connectives and two or more propositions, what we are going to create? We are going to create more complex propositions. So, for everyone, the question may arise that in our life we want everything to be simplified way, right? So, we don't want these complex things in our life, right? We don't like complexity. So, sometimes complex things are very much necessary in our life. So, and the things which are there in logical connectives are disjunction, conjunction, and then implication, and then biconditional. So, this is the very important topic under propositional logic. So, you should be very thorough about these logical connectives. They are disjunction, conjunction, implication, and biconditional. So, in this video, I am going to cover all these topics. So, let us first understand why we need this complex thing in our life. So, I will give you an example. So, let us take our everyday example. On morning, we will get hungry. Afternoon, we will get hungry. And at night, we will get hungry. Sometimes in the middle also, we will get hungry. Right? So, the thing is, I am hungry. So, if mom tells me to eat the food that is prepared at morning, okay, what will we do? We will say, no, I don't like that. This is one complexity. So, what will we think? Okay, the next scenario is, let's order pizza. So, I am hungry, that's why I will order pizza. It is simple, but sometimes what will happen is, your mom will allow you to eat pizza only during. So, sometimes what will happen is, your mom will allow you to order pizza only during weekend. So, I am hungry. This is one of the complex thing. Then, mom tell you to eat morning food. It is another complex thing. So, you think of eating pizza. It is another complex thing. But, mom allow you to eat pizza only during weekend. So, our life consists of many and many complexity in just food. In food, there is this much of complexity, and then what about our whole life? So, to simplify this complexity or to solve this complexity, we need complex proposition. So, let us take this example. So, I have told you before, if it's weekend and then I am hungry, then only I can order pizza. So, here both the statements should be true to order the pizza. So, there comes the complex propositions, right? So, if both the statements are true, then only you can order the pizza. Okay, so let us take one truth table, that is, I am hungry. Okay, I am hungry, true. I am lazy, I will not cook today. Then what will happen? I will order the pizza. I am hungry, I am not lazy, but today it's weekend. So what will I do? I am not lazy, but only on weekend I can order pizza. So I will order the pizza. I am not hungry and I am lazy. What will happen? It's weekend, right? So if I am not hungry, I will eat pizza. Right? So that's why it can be also true. But sometimes I am not hungry. I am not lazy. What will you do? I am not hungry. One thing. I am not lazy also. Then I will not order pizza. So in this scenario only you will not order pizza. So in all this scenario you can order pizza. So there are lot of complexity in our life, right? So these complex propositions are very important in solving the complexity of life or some decision making in computers. So I have told you that this is one proposition, right? And this is another proposition. So here two propositions are combined with the help of AND. So the logical connective here is AND. So let us go through the logical connectives one by one. These are all the logical operators, that is logical connectives in propositional logic. So first one is AND. AND means conjunction. Please remember this because many people get confused in the case of and or. Okay, so you may come across multiply and plus in computer science, right? So AND plays a role of multiplication. So here the main thing is both the statement must be true to become the whole statements to be true. So here true and true will only give you true. So which means, so let us take true as 1 and means into 1. What will be the answer? 1. If it is 1 into 0, then it will be 0. 0 into 1, it will be 0, right? So for conjunction means multiplication. So how will you remember? So conjunction, C here. So conjunction means multiplication. So in the case of conjunction, only true and true, that which means if two statements are true, then only the whole statement can be true. And or means this or this, right? So here its another name is disjunction. Here if any one of the statement is true, then the whole sentence can be true. That is here, if here plus, right? 1 plus 0 is 1. 0 plus 1 is 0. 1 plus 1 is also 1. Because in computer science we have only two things, that is zeros and ones, right? So 1 plus 1 is 1. The only thing is 0 plus 0 can't be true. So here the false will come only when the two statements are false. And then negation. So which means negation, it has another one symbol, that is this one. This one is the another symbol of the negation. Got it? So this is the another symbol of negation. Please remember this symbol. So here if it is true, negation of true is false. Simple. It is rhyming, and the negation of rhyming is it is not rhyming. It is very simple. And then comes implication. Implication you might feel quite complex when you first go through the implication and by condition. But after solving some of the examples or after going through these two topics very thoroughly, it will be very much easy for you to understand. So I will say some of the tricks to understand this. Here implication also stands for if then. Okay, if first statement is true, please remember, if first statement is true, then only second statement must be true. So if first statement is true and second statement is true, and the whole answer will be true. In implication what will happen is, in many of the case, please remember this, if first statement is false and second statement is true, then the truth table will be, or the final result will be true. So remember this. So in by conditional, this one is easy. Here both the statements should be true or both the statement should be false for the whole sentence to become true. So here false and false. What we actually write false, but in this case false and false will become true in biconditional. It is also called if and only if. So let us write the truth table one by one. Okay. First one is and. So here P, Q and P. What is the symbol? And, right? So P and Q. Here the truth values may be true, 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 false, false, true, false, false. Okay. So here what we are going to take? Multiplication, right? So here 1, 1, 1, 0, 0, 1, 0, 0. 1 into 1 is 1, 1 into 0 is 0, 0 into 1 is 0 and 0 into 0 is 0. So this will be the truth table of AND. So here if only we get true and true, then only if two statements are true, then only the whole statement is true. So and the next one is the truth table of OR. So the truth table of OR will become P, Q, P or Q. Here true, 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 false, false, true and false, false. Here plus, right? True plus true, true. True plus false also true. False plus true is true. False plus false is false. Simple thing what you can do is 1, 1, 1 plus 1, 1, 1, 0. 1 plus 0 also 1, 0, 1. 0 plus 1 is also 1. If 0, 0 is there, then the answer will be 0. So in this scenario only the truth value will become 0. So it is about OR. And then what? Negation. I will show you here only because it is very simple. P not P will be the truth value. If it is true, then false. If it is false, then it will become true. This is the simple truth table of negation. And then comes implication. You might feel this as bit complex, but no worry. I will tell you one small trick. Okay, from this it will be easier for you to understand. P, Q, P implies Q. Same thing. True, 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 false, false, true, false, false. True, true, true. Right? False, false. Here write it as true. Simple. Here in this case, true, false will become false. False, true will become true. You may feel how it become true and how it become false like that, right? So I will tell you a simple thing. In Q, if there is false and if the result it will become false. In Q, if it is true and in the result it will become true. So this is the simple thing you can understand. First fill the first column, first row and last row. And then by saying the Q value, you can fill the second and third one. So I will do changes here for biconditional. I have told you before that if both the statements are true or if both the statements are false, then the whole sentence will become true. So here both the statements are true, false. Same thing. Here you have to write it as true. Here in this case it will become false. This is the only changes in biconditional because here both the statements are not true. So it will become false. Here also both the statements are not true, then it will also become false. So these are the things about the logical operators. So if you feel something like bit tricky or something complex, don't worry about this. I will explain you this briefly with the help of examples in the next video. So do watch next video to get better understanding. Thank you.